All right, everybody. This is it. Welcome to Algebra 3-4 class. This will be our first video, our first lesson for the first unit. Just getting started right now. Okay. Our first unit we're going to be covering is on functions. So, we're going to focus. So our first lesson for the whole unit, it's just going to be an introduction to functions. What's a function? We'll talk about a couple of words, domain and range. So let's get started. I'm going to try to keep it short, sweet, simple, and we'll go from there. So here we go. I started out I want you to understand that what domain and range are. We'll start with that. Okay, we have or input, output. So one way, there's lots of ways to represent what you're seeing here. One way to represent it is we have these three numbers, 1, 2, 3, that I wrote over on the left, and then we have some numbers I wrote over on the right. And by putting an arrow going from one of the numbers to the other number on the right, we're showing that what we're saying is when we input, if we were to, whatever this function is, we don't, there's no equation or anything right now, but whatever it is, if I put a 1 in it, it's going to lead to an answer or an output of 4. Okay, well, here's our first vocabulary words. Our inputs, the things that we plug into a function, or in this case that we represent by our starting spot, and then it leads to this. The one that we start at is called our domain. Simple as that. This is the domain. Think of it as the inputs for a function. And then our outputs, the things that we get once we plug those numbers in, is called the range. This is always going to be true the whole year. Now, one way to write this situation, the way I did here with the starting spot, the arrow to the other thing, there's other ways we could have written that. That could also just be the points, 1, 4, 2, 5, and 3, 6. Of course, points we could also have written as just a smoother version of that. Might be when we have a lot of them, we could make a table. Maybe this is called X and Y, and it would just be 1, 2, 3, 4, 5, 6. Now let's talk about the word function, which is, the name of this lesson was functions. The name of the whole unit's on functions. So since it's the introduction lesson, we're just talking about what is a function. As we move along, we'll work with them. We'll do, different equations and things and graphs. But right now, just what is a function? So what's going on here is that if I pick any x value, and this as a whole situation here, this is a function. The reason it's a function is because any particular x value that I pick, there's only one y value that goes with it. So 1 goes with 4, 1 doesn't also go with 5. Okay? And then 2 goes with whatever, it goes with 5, right? But notice 2 only goes with 5. We don't see a 2, 5 and a 2, 6. And of course 3 just goes with 6. The first one I just made it as clean and simple as I can make it. 1, 2, 3 going to 4, 5, 6. No problem. This is a function. I think more important is when I show you the next example that's maybe not a function, it'll even make more sense. So here it is. Okay, what I'm going to do this time is I'm going to have the 1 go with 4 again. That's fine, no problems. But let's say we had the 1 had an arrow going to the 5 as well, and maybe the 2 goes to the 5 and the 3 goes to the 6. Whatever. So in this case, our points would be 1, 4, which would be represented by this arrow right here, but we also have this point 1, 5. And we have 2, 5, and we have 3, 6. But the issue here, the reason I made this example like this, is to show you right here. This right here is what messes up something being a function. If 1 goes to 4 and 1 goes to 5, You have the same x value going to two different y values, not a function. Now, as we move along here, I mean, you're going to see me in class and everything too. I'm going to, I'll get a little more detail as to why, but let me give you a quick, like, why is that not a function? What makes it so bad? And really what it boils down to is consistency. If I have this thing, which I would normally call a function, it should be consistent. It should be something meaningful. And to walk up to that function and say, hey, what happens when I put a 1 into it? Oh, you get 4. And then let's say I walk away for a second, I come back and I say, okay, I'm going to put a 1 into it. Oh no, you got 5 too. It's just not going to have that purity, that mathematical consistency that we're looking for in an algebra class. Doesn't make it necessarily bad. I mean, it's still, there is a name when the function isn't there, like in this case because of this. Everything still has what's relationship to it. This still exists as my made-up relationship that I just did, so it's called a relation. Relation just means basically not a function. It means, hey, we have something here, it is related, but it's not quite as special as we wanted it to be. It's not a function, so it's a relation. Okay. Any set of points, no matter what we do, we just sat here and just randomly made up anything for these. It doesn't matter what it is, we can always call it a relation because it's got two things related to each other, x and y. All right, here's another one. Let's go with, I didn't put the arrows in here. I wanted you guys to see me just kind of making these up because that's really all I'm doing here, okay? How about we're going to go 1 goes with 4, but this time we're going to have 2 going with 4. We'll have 3 going with 6 again, and that's it. We're going to ignore the 5. There's nothing. This 5 is just sitting there like a decoration, okay? So if we wanted to write this as points again, it would be the points 1, 4, 2, 4, and 3, 6. And let's just come out right now and just go ahead and say it. This is fine. This is what we'd still call a function. So some of you are thinking, well, what about the fact that there's the same number over here at the y value? Well, that doesn't mess it up. It's still a function. It's whenever we have the same x value. If you go back to the last one, you'll see that I had a 1, 4, and a 1, 5. Then doesn't have that purity, that consistency. But here it's just saying, look, if I plug a 1 in, I get a 4. If I come back tomorrow and plug a 1 in, I'll still get a 4. I'm not going to be shocked when something different happened. Oh, it just so happens that if I plug a 2 in, I also get a 4. But if I come back tomorrow and plug a 2 in, I'll still get a 4. So, I mean, I know you've talked about functions before, and maybe you even remember that you can't have the same x value in order to be a function. I'm just trying to get you started with kind of maybe understanding why and what's so special about that. And it's that whole idea that if you put something in a function and it gives you a certain thing, you shouldn't be able to come back later, plug the same thing in the function, and get a different thing. That's not going to lead to any kind of meaningful math problem. Now in the homework, you're going to see some graphs towards the end. It's a lot of what is in the homework is what I've already showed you, but then you'll also see some pictures. And so I wanted to point out a couple things here also. So on these problems, they're just going to ask you, well, first of all, we can talk about whether they're functions or not, and then we'll talk about domain and range. The same words, we're not going to change the words, we're just changing the fact that these are now pictures instead of just lists of points. So in both cases, I went ahead and drew what are considered functions. And the reason these are functions is you'll notice that if you're moving along this graph, there's only one x value. This is your x-axis is right here. And never is there a time where, for example, let's say this was, let's say right here is x equals 1. Well, there's going to be some spot 1 comma, whatever that y value is right there, right? But there's not going to be another 1 comma. There's no other point along 1. Same thing for 2, same thing for 3. Any spot you pick along here, You're not going to look up and down and see another point at that particular x value. Or in other words, there's only, for every one x value, there's one y value. So this is a function, no problem. So we can write function. And then as far as the domain and range. Domain and range. So now we have to think, it's not just a list of points. So we wouldn't just write down, for domain, we wouldn't put 1, 2, and 3, 5. We're not going to do that. It's more of a generic idea, which is, in this graph, if we start over at the left, which this thing's going on forever to the left. I know it looks like it's going up, but it's also moving slowly to the left as well. And same thing over here. It moves along, does this, and then it's slowly moving to the right. Domain is all about x values or inputs. And if you notice, if you read from left to right here, there's always a graph. If I start here, look for there would be a graph up here. If I keep moving along, look, there's a graph. If I keep going here, yep, still exists. This graph exists for every x value known to man. I mean, it doesn't matter. If I keep going here, there's an x value, yep, there's a graph over here too. So the domain here, because the graph exists all times from left to right, which is your domain this way, then the domain is everything. Or another real quick way to say that would be like, I'll tell you a couple ways. So all real numbers, meaning all numbers. Okay. And then another way that we can represent it is we make a parenthesis and we put our lowest possible value that we could have and then our highest possible value we could have. And these two symbols represent infinity. So what we're saying is the lowest is negative infinity, meaning forever to the left. And then this means forever to the right. So it's just another way of saying every number. Let's look at range though. So range here, you go this way. Start down at negative infinity and say, does the graph exist down here? I don't see a graph down here. If I look this way, as I'm moving up and up, I don't see a graph as I'm looking. The graph, there is no graph down here. Thinking of it up and down as because I'm talking about range here. But once I hit -1 right here, the graph starts to exist. And from -1 and higher, there's a graph. As I move up now, I'm seeing this graph, whether I have to look to the right, to the left, whatever, but it does exist. So the range for this problem is not all real numbers. It's going to be its lowest possible number, which is -1, to its highest possible number, which is infinity. We always put a curved bracket on infinities, and when we have a number, in this case we have -1, and we want to include -1 as part of our graph, as part of our range, because I think we do, right? If we go to -1 and we look, it looks like there's an actual spot at -1, that point right there. Okay? So when we want to include that point and say, you know what, including -1 and bigger, then we put a square bracket. Square bracket means include the number that you're talking about. And another way to say this, kind of the old school way to say this, is that the y values would have to be greater than or equal to -1. But we are going to use this method 90% of the time right here. It's called interval notation. Interval meaning from something to something. That's what an interval is. Alright, well, it looks like I ran out of room a little bit on the second graph I made. I should have just done that in a separate one, but we can still fit it in here. So on this one, same thing. It is a function. It's a function because once again, as I look at the x-axis here, remember we can't have matching x values or it's not a function. But as I cruise along here to the right, starting from left to right, there's only one location. There's not a point here or here. For any particular x value, you'll find one spot. So it is a function. Its domain is no longer all reals. On this one, the domain is going to be we'll assume this is a 1 right here. Okay? Then the domain is going to be from 1, including 1, to infinity. And the range is going to be from 0 to infinity. So remember, domain is left to right. You're reading it from left to right. So as I go from here, I don't see a graph, I don't see a graph, I don't see a graph, I don't see a graph. There's my graph. It starts at 1 in terms of left to rightness. And then from that point on, the graph is existing for all from 1 to infinity as its highest, which is forever. Okay. Range is the up and down, or the y value. This is the y-axis right here. Okay. If I start down at negative infinity, no graph, 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 graph. The graph starts when the y value is at 0. Like this point right here is 1, 0. So the y value's lowest number that can exist is 0. But then once it starts existing, then as I go up and up and up, it keeps existing. It's going to go up slower than it's going to the right, but it's also slowly going up. So the range is from 0 to infinity. There's a graph somewhere. I think we have enough to get you started, but I do want to make just one more point here. I haven't showed you this yet. Let me draw a graph that's not a function. You know, we know that something's not a function if it has two matching x values. So let's make something not a function. This is a good way to demonstrate this right here. So look at this. I'm cruising along, function, function, function. Notice I'm not, right now it's a function because no matter, as I'm cruising along this graph, I don't see another x value another y value that goes with a particular x value. But let's say I do this. Here's what messes it up right here. Go back the other way. As soon as you go back the other way, what you've created is some spots where if you draw a vertical line, it's going to hit twice. It's going to have basically the same x value twice. So in this case, you know, let's say this was 1, 2, 3, 4, 5, 6. So if that was at 6, then we would have, say, we'd have a point 6, 1, and we'd also have a point 6, negative 1. This is positive 1 up here. That messes up function. This is no longer function because we have the same x value twice. So if there's ever a time when you can draw a vertical line and it hits the graph at 2 places or more, it's not a function. Some other quick examples of that would be, you know, like a parabola sideways u, like that. Anything, you know, something like this, a v going this way. These are not functions. All right, so that's just a little introduction to functions and domain and range, and you know, we'll continue our discussion in class and work on the homework. So I hope that helps. Work hard, be nice. See you soon.